So another way of attacking this is to let x be the number of days making teddies and y be the number of days making Sarah. And they both have their advantages, this one and the one I just did, so take your pick. Let's see, so we have 20 days to manufacture, so we have the number of days making teddies plus the number of days making Sarah has to be less than or equal to 20. I can manufacture 60 teddies per day, so 60 times the number of days making teddies is the total number of dolls I make, plus 70 Sarahs times every day making Sarahs is the number of Sarahs I make, and that has to be less than or equal to 1,300 dolls maximum. So dolls plus dolls equals dolls. And the other one was days plus days equals days. So anyway, so those are our equations, and of course we always have x greater than or equal to 0, y greater than or equal to 0, because we're not making negative dolls. And so now we're going to graph all these and find our feasible region. So we're in the first quadrant. This guy here, y-intercepts of 20, x-intercept of 20, slope of negative 1 if you put it into y equals mx plus b form. So we'll just kind of quick graph that line. And then this one is a little bit messier here. If I put it in, if I solved for y, I get negative 60x plus 1300. When I divide, that's negative 6/7 x, and then this is roughly like 8.6. It's not perfect, it goes on a little bit, but for purposes of graphing, I'm just going to graph it at about 18.6. And then since my graph is already kind of imperfect, I'm going to go ahead and just grab the x-intercept. So when the y is 0, 1300 divided by 60 gives me about 21.7. So I'm over here somewhere, and I will graph that line there. And it meets somewhere there. And let's find out where that meets, because that's going to be a coordinate of one of my feasible region. So what I'm going to do is, because my graph is kind of imprecise this time, I'm going to go ahead and take my two equations, two unknowns, and use substitution or elimination. So I know that the y will equal negative x plus 20, and so I'll substitute that into here. So I'll have, or actually, the way I do it on here, just to keep it the same as what I did on the answer sheet, is I used elimination and I multiplied this top guy by a negative 60. So you could do substitution or elimination, doesn't matter. So if I do the top guy by negative 60, I'll get negative 60x minus 60y. We're just going to do equals 2 now because we're just looking for the intersection of the lines. And that's going to be negative 1200. And then I'll keep the second guy exactly as it is. And we've rigged it so that those guys go away. Negative 60x plus 60x, bye-bye they go. Negative 60y plus 70y is 10y, and that's going to equal 100. Divide by 10, you get y is 10. And then plug that back in, looks like the x would be 10 as well. So that point there is 10, 10. So when we make our profit equation, our linear programming model says that any one of these extreme points could be the max or the min of another linear equation. So this one was about 18.6, so I have 0, 0, 0, 18.6, 10, 10, and then this point here was 20, 0. So now what I'm going to do is write my profit equation. So my profit, I'm making $30 profit per doll for the teddies. So I'm making $30 per doll. And remember, the number of dolls I make is actually 60 dolls every day. So I'm making 60x dolls. 60 teddies times every day making teddies, that's the number of dolls they make, $30 times every doll. So this gives me the money for the teddies. by the same reasoning, I can speak, the Sarahs I make $26 and then I make 70 Sarahs every day and making them for Y days. So there's the equation I want to maximize, and I'm going to plug all of these points in. So I'm going to plug in 0, 0, I'm going to plug in 20, 0, and I'm going to plug in 10, 10, and I'm going to plug in the 0, 18.6. If you keep an exact answer for this one, you do get that 33,800 like we did in the other one. So if you don't like let it go on your calculator and put it in just right with all the decimals and everything, it comes out perfect. If you do this one, if you don't make anything, you'll get 0. If you plug in 20 for the x and 0 for the y and punch that in on your calculator, you will get 36,000. And if you plug in 10 for the x and 10 for the y and plug that in on your calculator, you get 36,200. So who's giving me the maximum? This one here. $36,200 is the maximum amount of profit I can make, and that matches what we did before. So it's 36,200 profit, and this is when I spend 10 days making teddies and 10 days making Sarah. So that means that I actually made 60 teddies per day for 10 days is 600 teddies, and 70 Sarahs per day for 10 days, 700 Sarahs. Ha ha. And that matches what we got before. 2 ways, just what you've always wanted to know. You're welcome.